Because what we're actually doing is, we're measuring this idea of consistency. So last time around, we had this idea of measuring center. Measuring center. And we had all kinds of ways to do that. Averages, medians, modes, trimmed averages, all kinds of wonderful stuff. But the big idea for all of them was, okay, if I had to pick one number to talk about the typical value of this data set, what number would I use? And you can choose median, mode, average, whatever you want. But that's the idea of center. Now, we have this idea of measuring variability. Variability or variation. And this idea is, give me a number to measure not just the center of a data set, but the entire data set and how it spreads out. So for example, you want to go fishing in a pond, and your friend knows the pond really well, or the river really well. Where should I go fishing? Mile marker 3. Okay, you go right to mile marker 3, walk out to the river, start casting. I'm not catching any fish. That would be a measure of center. Because he's telling you mile marker 3, because from whatever his experiences are, on average, mile marker 3 is where he usually catches the most fish. But the problem is, he probably goes up or downstream from that a little bit. So you might want to additionally ask him, oh, okay, so when you say mile marker 3, what exactly do you mean? Oh, maybe as far down as mile marker 1 or as far up as mile marker 7 or something along those lines. So the idea is, the variation is still tied back to this. You don't want these independent of each other. You want them linked together. That's why, Lydia, I loved your idea. And I love the range from Katie. Not that they're bad. The problem with range and the problem with your customer called the L measure, for Lydia, totally fine. The problem with them is they ignore the average. They don't tie the average in. So it's almost like we have then two isolated measures as opposed to one cohesive two-part unit. Hopefully that sits well with you guys. That's why I like what Cody is starting for us. Let's use this basic idea up here, but let's link it into one that's actually commonly used. The one you're describing, Cody, is called average deviation. If you actually look at the difference, and add them all up and divide by how many there are, it's called the average deviation. It's extraordinarily commonsensical, and nobody uses it. It's unfortunate. The reason is very mathematical. If you want to know why at break, I'll tell you. But let's start developing the one that actually is used. Let's start developing the one that actually is used. I want to come over here on the front board to help us out with this. This is the only time you'll ever do this by hand, because the computation is a bit much. Even the one we just did, even if you write it out, is a fair bit of annoyance. So let's start with Ernie. Let's get this started, and then we'll take 5 break. Leave these up, I guess, for right now. Ernie. Okay. So let's measure Ernie's consistency. Let's see how we measure Ernie's consistency. Okay, dope. So the first thing I want to do to keep track of all this, I'm not trying to do math in my head. You see where that can lead us astray. I'm going to put the data points down. Ernie's exam scores. He had an 81, he had an 83, 82. What else did he have? 79? 80. That was it. Beautiful. So the first thing I'm going to do is I'm going to steal Cody's idea of taking away, finding the distance from average. So I'm going to start by taking each data point, x, and subtracting the average from that. Subtracting the average from that. And if I complete that little chart right there, this will be 81 minus 81, which will be 0. Which means there's no difference from average. Yay! 83 minus 81, which is 2. Yay. And continue. I told you not much math in this class. I told you. Not much math. 82 minus 81, 1. 79 minus 81, negative 2. 80 minus 81, negative 1. Now hopefully those numbers look familiar. They're the ones we had earlier when we did the little lines on the graph. Average them.
It's going to be 0.
It's going to be 0, isn't it? Because the plus 2 cancels a negative 2.
And the negative
The 1 cancels the -1, and then the 0 is 0. So you add them all up, you get 0, which means Ernie has no variance. In other words, he's perfectly consistent. Is that a true statement?
Yep.
Is that a true statement?
Yeah.
But he's not, is he? He varies a little bit, doesn't he? I mean, look at the scores. I see what you're saying, Aaron. Based on the calculation, yes. But the problem is, not perfectly balanced. You're saying perfectly balanced, thank you. Yes, he's perfectly balanced, perfectly symmetrical. But if he was perfectly consistent, would he go from like a 79 to an 83?
No, you would just.
He would go 81, 81, 81, 81, 81. You see, I like what you're saying. You're saying he's perfectly balanced, absolutely, just like Bert is on this screen. But if you talk about consistency, the only perfectly consistent would be you get the same score every single time. Does that make sense? So make sure we're talking the same language here. Good. Well, that's a bit of an issue now, isn't it? That's a bit of an issue. Now, but the question I have now is, was that just a fluke of calculation? Before we take 5 here, let's see if that would also happen with Bert. Now, Bert has an average of 81, correct? Okay, so this score of 61, the difference from 81 is -20. With me so far? -20. Let me put a little here. Do this without getting in the way. Okay, so this one is a -20 difference from Bert's average. This is what is this here? That's a 68, correct? 68 was what, -13?
Yeah.
Did I do that right?
Yes.
-13. 82 is a +1. 94, is that +13? 12? 13? Check my math on this. And he got 100, yes? Which is +19? Did I do that right? Average them. Average them. Right, you can tell my over now. What's it going to be again? Yeah, don't. Part of an average is adding up the values and dividing by how many there are. And what's nice about this is you look at the pluses and the negatives and cancel. -20 is going to cancel that 1 and 19, they're gone. And then -13 and +13 cancels. Holy crap. Why? Why are they canceling? Is it magic? No, it's not magic. Say that again, Lydia. Right! Go back to what Aaron said. When I asked about consistency, she answered with balance. The average is the perfect balancing point of a data set, right? That means you have to have the same amount of, if you will, weight on one side as you do on the other. So in other words, that's always going to happen. That's always going to happen, no matter what data set you have. Which means we can't just stop here. We have to go further. Now, Cody, the way you took care of it was you took absolute values. You didn't call this -2, you called it 2.
Yeah.
-1, you called it 1. And that took care of the negatives, yes? Unfortunately, that's not what's done in the world most of the time. It's rather unfortunate because it's very intuitive. Well, let's take 5 and come back and we'll see what actually is done in the world. Okay? But take 5. You guys don't look like you're getting a break. Walk around a little bit, yes? All right.